Good morning. Here you can see the topic. Topic is Gay-Lussac's law of gaseous volumes. This is a topic from the subject of chemistry. Uh, I discussed earlier. Total 5 laws are there. Okay, starting from law of conservation of mass. Okay, then came law of constant proportions or law of definite proportions. Then came law of multiple proportions. Then one more law should come, that is called law of reciprocal proportions. Okay, that law still I have not discussed. Okay, and the last one was Gay-Lussac's law of gaseous volumes. In this video, I am going to discuss about this law. All the earlier laws are related to the mass of the substances or the mass of the elements or the mass of the compounds. Okay, but here in this law, Gay-Lussac's law of gaseous volumes, this law holds good only for gases. Okay, here reactants are gases and also the products are gases. Okay, reactants as well as products all are here gases. Gases, and we are talking about here means this law talks about only the volumes of the gases, not the mass. Okay, so what is that law? Suppose there are 2 or 3 or 4 reactants, whatever be the number of reactants, that doesn't matter. Here in this law it is stated that of course one thing is there, one condition is there, that since we are talking about only gases, so the volumes of the gases must be measured under similar temperature and pressures. Under similar temperatures and pressures. Okay, same temperature and same pressure should be there. Okay, say the temperature is 300 Kelvin and pressure is say 1000 Pascal. I am just giving you example. So these numerical values must remain same along with the units. Units also must remain the same. Okay. So under similar temperature and pressures, if reactants react to produce products, okay, so in that case the volumes of the reactants as well as volumes of the products, of course if the products are also gases under that temperature and pressure condition, then all of them means reactants as well as products, they will bear a simple whole number ratio. That is called Gay-Lussac's law of gaseous volumes. Okay, as for example, hydrogen and oxygen both are in gaseous state. Okay, hydrogen and oxygen combine together, means after reaction, combine together to form water vapor, means steam. Water vapor means steam. Okay, and what is the reaction? The reaction is like this: H2 plus O2. From here what you get? H2. After chemical balancing you will get what? This is hydrogen. 2H2 here and here 2H2. Is that visible? Yeah, it is visible. This is 2 and this is also 2. Okay, this is water vapor or steam, right? Now I think everything is visible. 2H2 plus O2 is equal to 2H2. I should give here equal sign. Okay, after chemical balancing you can write this way. So here how much volume of hydrogen is there? Here 2 is there, so it is 2 volume. Okay, volume wise it is 2 2 unit. Okay. Here oxygen only 1 unit. And here water, not water, you should not say water, you should say water vapor or steam, either water vapor or steam. And here steam is 2 volume. So what is the ratio of the reactants as well as the products? Ratio is 2:1:2, which is a simple whole number ratio. So this was an example to explain Gay-Lussac's law of gaseous volumes. Okay. One more example can be taken. Actually, there are numerous examples. So to explain this law, one more example can be taken. That is the reaction between hydrogen gas and chlorine gas. Okay. You know, hydrogen and chlorine combine together to form hydrochloric acid. Okay. So write that here. This is hydrogen, this is chlorine, Cl2, and we get hydrochloric acid, HCl. So chemical balancing will give you 1 hydrogen molecule plus 1 chlorine molecule will give you 2 hydrogen chloride molecule. Here hydrogen and chlorine are elements, and hydrogen chloride or hydrochloric acid, that is a chemical compound. Okay. So volume wise, here it is only one unit, 1 volume. Okay. Here it is also 1 volume, 1 unit. You can say also 1 unit instead of writing VOL for volume. Okay. You can also write unit, this much of unit. Okay. And here it is 2 unit or 2 volume. Right. Then what is the ratio? The ratio is again here 1:1:2. This is also a simple whole number ratio. Okay. So these are the examples to explain Gay-Lussac's law of gaseous volumes. So one condition is there that must be fulfilled while discussing this law. That condition is everything will be measured. Everything means volumes of the gases, whether it is reactants or whether it is products. Okay. So volumes of the reactants as well as products must be measured under similar temperatures and pressures. Okay. That is the condition which needs to be fulfilled during the experimentation. Okay. So this was all about Gay-Lussac's law of gaseous volumes. Okay. So this is the end of this lecture. Thank you. Thank you for watching this video. Have a nice day.